Good day, esteemed students. You're welcome to this edition of presentation on physics. So in today's edition of class, we're going to be looking at what is internal resistance. I'm also going to be looking at series and parallel arrangement of resistor. So in this series, we define internal resistance as the opposition offered to the flow of current by the chemical content of the cell. So what are we trying to say? What we're trying to establish here is that the actual thing that offers the opposition of current is what? The chemical content of the cell. And that's the reason why it is called internal resistance. Now, we have another one, which is series arrangement of resistor. Now, when you look at this now, this is how resistors are arranged in series. They are being arranged horizontally. Here we have our R1, R2, R3. So if you're asked in exam to calculate your total resistance in series, the student is expected to sum the values of individual what resistor. So like I have here my uh, R total, which is the total resistance in series, is R1 plus R2 plus R3. And for example, let's assume your R1 is 2 ohm, and your R2 is 4 ohm, and your R3 is 5 ohm. You are asked to calculate this the total resistance in series. So the student is expected to say that the total resistance in series will be 2 ohm plus 4 ohm plus 5 ohm. And when you do that, it will sum up to 2 plus 4 is 6, and 6 plus 5 is what? 11 ohm. So this is how, or this is the ideal way to solve your problem as regard to the arrangement of resistor in series. So having known that, it is also evident that I show you how you can also solve problems of resistor when it's arranged in parallel position. So here we are meant to know that if assuming now this is a resistor now, and this resistor is arranged in this format, and let's say we have another one here, and we have another resistor here, and let's assume here is R1, and here is R2, and here is R3, and here is R4. And you're asked to get the total resistance in parallel. Total resistance in parallel. So your R total in parallel is going to be the reciprocal, which means 1 over, is going to be 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3 to infinity, or to where you want to stop. So assuming now that the respective values, R1 is given as, let's say, 3 ohm, and then R2 is given as 4 ohm, and then your R3 is given as 6 ohm. And you're asked to get your total resistance in parallel. So it's going to be 1 over R equals to, already know the values, so there's going to be 1 over 3 plus 1 over 4 plus 1 over 6. So if you look at this now, we are now going to solve the resulting fraction. We have 3. So the LCM of 3, 4, and 6 is going to be 12. So 3 divided 12, we are having 4. 4 times 1 is 4. Plus 4 divided 12, we are having 3. 3 times 1 is 3. Plus 6 divided 12 is 2. 2 times 1 is what? 2. So which means that if we continue from here, we have that 4 plus 3 is 7. 7 plus 2 is what? 9. So we have 9 over 12. So for us to actually get our resistance, okay, let's break this down a little bit. This 3 will go here, it becomes 3. Go here, it becomes what? 4. So which means that our 1 over R is equal to 3 over 4. And this also implies that our resistance, if we remove its reciprocal sign, we are going to have 4 over 3. And that is our resistance. So when you get the quotient, that will be your resistance in ohms. So this is what parallel arrangement require you to do. So you need to know how to solve this problem when you are given. All right, if you look at there, we have a model of this very information I've shared with you now. Looking at this is parallel arrangements of resistors. So let's see the question and see what it's all about. The question says we should find the effective resistance of the above combination. We should find the effective resistance of the above combination. Let's see what is going to happen. Now, from the above combination, so the effective resistance is going to be, since it's in parallel, it's going to be 1 over, we are now solving now, solution to number 1 question. One question that we have here is now going to be 1 over 6. So we say 1 over R is equal to 1 over 6 plus 1 over 9 plus 1 over 4. So if we proceed further, we now say that 1 over R, the LCM of this and this, the LCM should be 36. Okay, 6 divided 36, we are having it to be 6. 6 times 1 is 6. 9 divided 36 is 4. 4 times 1 is 4. And then 4 divided 36 is 9. And 9 times 1 is what? 9. So that means that we are going to have 6 plus 4 is 10. 10 plus 9 is 19. So we now have 19 over 36. So therefore, when we want to get our resistance, it's going to be, we turn this very fraction upside down. We have 36 over 19. So when you divide out, whatever you obtain is your answer in ohms. Okay, this is how to solve this very problem if you are given such problem to solve. Okay, that's number 1. We have trashed that number 1 question. So let's go to the next one. We are told that in this diagram that we should calculate the resistance as well. Now, for us to solve this very problem, it's going to be we sum all the whole quiz, we total all the whole resistance for us to be able to know the effective resistance here. Okay, I believe you understand this class, and the more you pay attention to this class, you'll be able to understand it properly. So I'm going to leave this one for you so that you can play with it, solve it by yourself. Maybe in the next class, I shall discuss that with you. Then I also have here in the circuit diagram above, calculate the current in 12 ohm resistor if the cell has an EMF of 12 volts. Okay, I'll do this number 3, so I can do number 2 as your as something for you to do. Okay, so here in this solution 3, you are going to put the formula that your EMF is equal to your current multiplied by your external resistance plus your internal resistance. So like I always tell you in the classroom, that you must write out your parameters so that you can be able to know how to use your formula. So you must write out your what? Parameters. Okay, let's go to the question and see what are the parameters. We are told that in the circuit diagram above, calculate the current in 12. So that means the current, we are looking for the current. So the current is unknown. And here we have 12 ohm resistor. If the cell has 12 volts. Okay, so that means this external resistance is what? 12 ohm. Then we are told that if the cell has an EMF of 12 volts, that means that the EMF is what? 12 what? Volts. And we also told that an internal resistance also, that means the small r is what? 1 ohm. So with this information we have gathered, it will be easier for us to start substituting. So we make our current insulator formula. If you make current insulator formula here, we are going to have that our E of we're going to have our current to be our E over R plus what? R. So which means that our current is going to be, what is our E? Our E is 12. And what is our big R? Our big R, which is external resistance, is 12 ohm. So plus this one, which is 1. So therefore, our current will now be equals to 12 over 13. All right? And whatever we have now will be our answer in ampere. All right, thank you, students. I believe you enjoyed the class. It is at least I've been able to consolidate your idea on the topic resistor in series and in parallel. Thank you for your audience. In our next edition of class, we shall continue on this very topic. But in what we are going to be treating is cell, and it's going to be exciting like what we have here. Thank you.